Hello everybody, today we are gonna take a look at developing QVM smart contracts on Linux. For this tutorial video we will be using one of the, or actually the most widespread Linux operating systems, which is the Ubuntu Gemmy Jellyfish 22.04.1. So this is the long-term service branch. So let's jump right in. Let's head to the tutorial website. This is completely fresh installation. Actually, it isn't even installed yet. So this operating system is running from an installer drive. So it might be a little bit slow, but it's a completely clean system to ensure that there are no dependencies installed ahead. So if you follow this, you're gonna get the results you're expecting. Okay. Here it is. So here is the generic description. And yes, here it starts. So first we will need to install Docker because that's a dependency. So all the components, including qvmctl and the compiler, are both Dockerized versions to ensure that they are running in the very same way across all the operating systems. So for that, we're going to need to open terminal and we can install Docker. Yeah, so there isn't even kernel installed yet, so we will need to fetch that first. We are not installing any other updates here, but it's always good habit to keep your system updated. So you could also do an apt-get update and upgrade as well. Okay. Now it starts installing. I'll pause the video until this is completed. So Docker has been installed. Let's see whether it's also started. No, we will need to start the service. Okay, maybe we need to add ourselves to Docker group. But we would need to log out here as well. So the easiest way to do that is to just use sudo for Docker commands. Yeah, this way it works. Because even though if you add yourself to the Docker group, like here in this command, you would need to log out and log in again for these changes to take effect. So we will be just using sudo in front of every Docker command, and that should work fine. So first, let's pull the image, qvmctl, then prepend sudo to the front. Okay, now we can check that the correct version has been downloaded. Yes, it says version 0.0.2 as it should. Setting up our workspace, so we just create a directory called workspace and change directory into it. We also need to generate a random private key, which we will use for the experiment. You can see that our private key was created. Now we need to determine our wallet address, which is done by running this command. You need to mind the dot at the end of the command. Make sure you copy that as well. And we need to prepend sudo here for this example, but it should work without sudo if you completed the previous steps and you logged out and logged in, as I said. So this is our wallet address derived from our private key, random private key, which we generated here. So we will use that to get some testnet ether, RUPS and chain. So we will need to copy this address, paste it right here, and get RUPS and Ethereum. We can go here. .io, sorry. Yes, so we will wait for the testnet ether to arrive. It says here that it could take half an hour. Usually it's much quicker. I'll pause the video until it arrives anyway. Okay, so we received our 10 testnet ether. So we can continue here. We can close the faucet tab now. Writing smart contracts. So currently there is instructions for Golang. So this is what we are going to use. Writing smart contract in Go. So this is a pretty simple application. It allows us to register users into the database. So it only accepts a single argument or a single command register and another argument passed to it. So it will fetch the current username from the database. If there is no length of the previous name, that means the previous user is unknown. In case that this is the first running of this command, then the total user count is fetched from the DB as well, converted to an integer. Then we will write to standard output the previous username, and we will write to the database. So the DBW stands for database, right? The current username, which was passed as an argument, and we will also persist this username under storage slot, so we can retrieve them later. And we are also gonna increment the total user count here. Otherwise, so if there are more arguments or anything, we will exit with code 0. Otherwise, the program ran successfully, so we're going to exit with code 0. In case it was wrong, we are going to exit with code 1. So I'm going to copy this example and paste it into the main.go file as instructed here. Okay. Now let's go ahead towards compilation. So we will compile with the QVM compiler. This will result in a much lower, smaller binary size, which will give us huge savings on the deployment cost. So again, we need to prepend sudo for the Docker commands in this example. You shouldn't need that. I'll pause the video until the download completes. Okay, so it's completing the compiler download. Now it is extracting the last layer. And as soon as this is done, it will immediately start compiling the binary. So that's already running. Okay, so this command returned, which means that our binary should be ready. We can check that by listing the contents, and there we see our contract binary there, which was compiled for us. And we just need to deploy that now. So now our contract is compiled. We can close this tab. Here are the compilation instructions for Go, which we just completed. Now we head to deploying a smart contract, which is the same for all languages. Yes, we just checked the contract size. And now we need to deploy the contract. Let's copy this command. Again, prepend sudo here. Most likely you shouldn't. And here we specify that this is a deploy operation. We specify which private key to use, which is in our current working directory, and the binary, so the contract name, which says just contract. So these are the arguments. Just hit enter. Connect it to the QVM repository with our wallet. The deployment fee was calculated. The contract has been deployed to IPFS, and the IPFS deployment was verified. Proof was calculated by one of the registrants, and now we are waiting for contract registration. So we see here that our contract is already on chain, and now we are waiting for the registration process to be accomplished. You can check, so this right here is an actual contract on the chain, so we can check that. Go to Robston. It should be already alive. Seems to be a bit slow these days, but should load just fine. Maybe Etherscan isn't aware yet of the contract itself. Yes, so here we can see that it was deployed and it was already registered 26 seconds ago. So, okay, now we should also, for the next examples to be easy, we should export the contract address into a variable. For the next couple of commands, let's get back to the documentation. Here we can read, by the way, what's happening when the contract is deployed. Next, let's go ahead to calling a smart contract function. So this is a generic description of how calling smart contracts works, because, well, it obviously depends on the smart contract itself, what kind of functions you can call, what kind of parameters you should use. I mean, in terms of how much memory you need for that, how much timeout is required. For this example, which we just deployed, I'm going to enter these values manually. So sudo docker run So this is going to be a call operation. Let's give it some memory of 10 megabytes, which is, let me calculate, how do I open a new tab here? Okay. So let's give it 10 megabytes, give it a timeout of 3000 milliseconds. We are gonna read the current name. It's called current name. Let me check. What the database entry key was. User current. User current. Also, we're gonna need total users. We will be writing 3 slots, so we need to specify how many database slots we are going to write in this operation, which is 3. We can count them here, and this operation will write to 3 slots. We need to specify that. Also specify the private key, which we're going to use. Then put the contract address and register as the command name, which we can see here. So this is the register function, and let's call the first one first name. Yes, now we see that this smart contract call fee of this much is covered by our balance, and that now we are calling the register command on this function. On this contract. Yes, now it's already being executed. We can check the status live on the Etherscan as well. It's a bit slow, but we can see here that it already executed. So the previous name was unknown, as we have seen in the contract code, because this is the first call. And why doesn't it load? Yeah, here we can see that it was successfully executed. So we can now we can register the second user actually. This is the very same command, but you're gonna see that the previous name will be, of course, first user or first name, which we just set, instead of unknown. And also in the next stage, I'm gonna go there in the documentation. Reading smart contract storage. We can read multiple fields. So this is the generic syntax to query a smart contract storage. So we will query the contract address and the database slots we are interested in. We can see that it's completed already. So now the previous name was first name as expected. So let's do a query operation. At the workspace. We have saved the contract address in this variable. And now let's query. Actually, I'll go back to the contract code so it's easier to understand what's going on here. Writing the smart contract. Go. Okay. So here we can see that the database keys being used are user underscore and then a numeric value which represents the number of user which is stored under that slot. the user current, it always points to the most recent user which got registered in the database. And the total user is a counter of how many users in total we have. So we are going to query these variables. So the user current, the user 0, which was the first user, user which we just registered, and the total users, which is the counter. Just hit enter. Okay, I added another, because we see here that yes, there are 2 users in total. The first was first name, the current is second user, but for this is empty because I put another underscore here by accident. So now it should work just fine. Yes, as expected, this is second user. User 1 is second user. And also if we want some nicer output, we can install JQ and pipe the output into that. That's just cosmetics. Let's pipe it like this. Yes, so this is the expected outcome. So this is the storage of this current contract as of now. And also it's important that, as you see, there is no private key parameter here because contract storage is of course public. So that's actually stored on chain on Ethereum Ropsten in this case. So anybody can query. If you run this very same command on your machine without following this tutorial from the beginning, it will work just like that. So I can expand this. So if you want to run it, then you can run it like this on your machine and it should work just fine. As you see. So that was it, showcasing the basic example how to develop QVM smart contracts on Linux in Golang in this case. Hope you enjoyed it. If you have any questions, then post them in the support Discord and stay tuned for more videos to come for more languages and more operating systems. Thank you. Have a great day.